Hello students, today we want to learn how to pick objects without replacements. We are considering a situation whereby we are looking at the probability of picking object without replacement. Let's look at this particular example. A bag contains identical balls in which 6 are red, 8 are white and 4 are blue balls. 3 balls are drawn from the bag one after the other without replacement. So what does it mean? Then without replacement, let's look at it. We are told that from the bag we are having 6 red. So that means if these are the balls, we are having 6 balls here, 1, 2, 3, 4, 5, 6. Then we are having 8 of the balls are white. If these are the 8 white balls, 1, 2, 3, 4, 5, 6, 7, 8. And we are having 4 blue balls. If these are the 4 blue balls, 1, 2, 3, 4. Now, if from this bag I want to pick a ball without replacement. Now, if I'm picking my first ball to be a red ball. Now, how many red balls do we have in the bag here? So I'm having 6. So it will be 6 over the total number of balls here. 8 plus 6 plus 8, 14. 14 plus 4 is 4, 18. That should be 6 over 18. So this to the lowest term will be 3 here 2, 3 here we having 6. This can still be 1 over 3. So that means if the probability of picking the first ball is 1 over 3. So assuming I've picked the first ball to be red, I've cancelled out this red. So you realize that now I'm now having 5 red balls left. I'm having 8 white balls. Then I'm having 4 blue balls. The total number of balls will now be what? Will now be 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that means I will now be having, since I have picked one ball out, I'm now having a total of 17 left. Now, if I'm to pick the second ball, I want to pick the second ball now, so to be red. So the probability of picking the second ball to be red. How many red balls do I have left? I'm having 1, 2, 3, 4, 5 red balls left. That will give me 5 over the total number of balls remaining is 17. So the probability of picking the next ball to be red will be 5 over 17. So this is it. I've picked the next ball to be red. So that means I'm having how many red balls left here? I'm having 1, 2, 3, 4 balls left. The total number of balls is now reduced to 16. If I am to pick the third ball, I want to pick the third ball. The third ball, what's the probability of picking the third ball again to be red? So how many red balls do I have left? I'm having 1, 2, 3, 4. 4 red balls. So that will give me 4 over the total number of the remaining balls will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That will be over 16. This to the lowest term will give me 1 over 4. You can see that as you are picking one ball without replacing, you realize that the total number of balls will be reducing, and a particular color will also be reducing. So try to understand the procedure. It is different from the previous. Now let's consider this again. Assuming all the balls are back in the bag, we are having 6 red balls, then we are having 8 white balls back in the bag and 4 blue balls in the bag. Then the probability of picking the first ball to be white. The probability of picking the first ball to be white. How many balls are in white balls and the bag? We have 1, 2, 3, 4, 5, 6, 7, 8. The probability of picking the first ball to be bag will be 8 over the total number of balls here is what? 18. This to the lowest term will give us 2 years what? 4/9. Now, the probability of picking the first ball to be white is 4/9. So I'm going to cancel one white ball here. So now that means how many white balls do I have left? I'm having 1, 2, 3, 4, 5, 6, 7 white balls. So the total number of balls I'm having left will now reduce to 17. Now I now want to pick the second ball. The probability of picking the second ball to be what? To be red. What is the probability of picking the second ball to be red? So how many red balls do I have here? 1, 2, 3, 4, 5, 6. So I'm having 6 over the total number of balls is now what? 17. 6/17. So I'm going to what? Remove the red ball that has been picked. Now you realize that total number of balls has reduced to 16. The remaining red balls are now reduced to what? 5. Now I want to pick the third ball. The probability of picking the third ball to be blue. Then I'll now, how many blue balls are here? 1, 2, 3, 4. That will give me what? 4 over the total number of the remaining balls will be what? To be 16. That will be 4/16. Which is same thing as 1/4. 1/4. So when you are picking objects without replacement, without returning it, so that means the total number of balls will be reducing and that color will also be reducing. Now let's look at this other example. We want to pick 3 balls again. So the probability of picking the first ball. The probability of picking the first ball to be blue. How many blue balls do I have here? I'm having 4 blue balls. So that means that will give me 4 over the total number of balls is what? 18. So I will cancel 1. I've removed 1 blue ball, remaining 3 blue balls. Now I want to pick the second ball. The second ball, I want it to be red. How many red balls do I have here? I still have 6 red balls. That will give me what? 6 over the total number of balls has reduced to what? 17. That will be 6/17. So I've removed 1 red balls. Then I want to pick the third ball again to be red. So how many red balls do I have in the bag now? I'm having 1, 2, 3, 4, 5. I'm having 5 red balls left. 5 over the remaining total number of balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It now remains 16 balls. So that will be what? The probability of picking the third ball to be red will be what? 5/16. 5/16. So this is the effect of picking balls without replacement. Now let's consider this example. A basket contains 3 red balls, 5 blue balls and 7 green balls. 2 balls are picked one after the other without replacement. Find the probability that both are red, both balls are red. Then B, the probability that the first is blue, the other is green. Then C, the probability that one is blue, the other is green. D, the probability that both are of the same colors. And E, the probability that they are of different colors. So to solve this question, you realize that we said in the bag we having 3 red balls, 5 blue balls and 7 green balls. So these are the balls. So these are the 3 red balls, 5 blue balls and the 7 green balls. So the probability of picking the first ball to be what? To be red. The probability of picking the first ball and second ball to be red. So this, we are doing this without replacement, because from the question it says one after the other without replacement. You must take note of this. In the previous video, we learned how to do it with replacement. That means we pick one and return it. But this time around, when we pick one, we are not going to return it. What is the probability of doing that? So differentiate this question from the one we had in the previous video. So now the probability of picking the first ball here to be red with what? How many red balls do we have here? We have 3 over the total number of balls give us what? 3 plus 5, 8 plus 7 is what? 15. 3 over 15. Then the probability of if I now pick one red ball here, now you realize I'm now having 2 remaining red balls, 5 blue balls and 7 green balls. The probability of picking the second one to be red again will be what? How many red balls do I have left? I'm having 12. I'm sorry, 2 over the total number of balls has now reduced to 14. So since this is an independent event, so the two are supposed to happen simultaneously. So I'm going to multiply the probability of picking the first ball to be red times the probability of picking the second ball to be red. So 3 over 15, that this one seems that 3 here 1, 3 here will give me 5. 2 here 1, 2 here will give me 7. So that means you now have what here? 1 times 1 will give me 1 over 5 times 7 will give us 35. So the probability of picking the first ball to be red and second ball to be red will give us 1 over 35. Let's look at the second part. B says that what's the probability of picking the first to be blue and the other is green? First to be blue and the other is green. Here we are given the arrangement of the way we want the balls to be selected. We are saying that we want the first ball to be blue while the other balls to be what? To be green. So for us to solve this, we have 3 balls in the bag, 3 red balls, 5 blue balls and 7 green balls. The probability of picking the first ball to be blue. So how many blue balls do you have there? 5. 1, 2, 3, 4, 5. That the first ball to be blue is for 5 over the total number of balls will give us what? 15. Then if I pick these blue balls, so I picked 1 blue, so remaining 4 blue balls. Then we want to pick the second ball to be green. How many green balls do we have there? That means we are having 7 green balls. Then you realize that the total number of balls has now reduced to 14. Should be 7 over 14. So since these events are bound to happen simultaneously, that means we multiply the probability of picking the first one to be blue and the second one to be green. We are going to multiply the two probability. So here you having 5 here is 1, 5 here will give us 3, 7 here 1, 7 here is what? 2. So that means we'll be having 1 times 1 is what? 1 over 3 times 2 will give us 6. Now let's consider this part C of the question. It says, what is the probability that one is blue and the other is green? The probability that one is blue and the other is green. You realize that here, this particular question is not giving us the arrangement of the color, how the colors will be selected. So it is either we have the first one to be blue and the second one to be green, or we have the first one to be green and the second one to be blue. So now if we want to take the first one to be blue and the second one to be green, so if we are having how many blue balls are there? So we are having 5 over 15. We have 5 over 15. Then if we now, after picking the first one to be blue, so the probability of picking the second one to be green is how many green balls are there? We are having 7 over 14. The total number of balls has reduced to 14. Because these two are meant to happen simultaneously, we will multiply them. Then because this is it is either we have this or we have this. We are now going to add them to the result of this. The probability of having the first one to be green, the probability of having the first one to be green is what? 7/15 times. Now realize by the time you remove one green here, it will remain what? 6 greens. Then the probability of picking the second one to be blue, how many blue balls do you have now? You still have 5 blue balls. The total number of balls has now reduced to what? 14. So that means you multiply this result times, you multiply this result, you now add them, because it is only one of this situation that can happen. So I'm having 5 here 1, 5 here 3, 7 here 1, 7 here 2. So that means you have 1/3 times 2 here is 6, plus we have 1/6 plus 7 here 1, 7 here 2, 5 here 1, 5 here 3. 1 times 1 is 1/3 times 2 is 6. When you add the two, so these are like fractions. So the LCM of this one, LCM is 6. How many 6 and 6? 1. 1 times 1 will give us 1, plus how many 6 and 6? 1. 1 times 1 will give us 1. 1 plus 1 is what? 2/6. 2 divided by 6 is same thing as 1/3. The D part of the question says that we should find the probability that they are of the same color. We realize that in this question we are having different colors. So it's either we have it that the two balls are red, we pick red first, red second, or we pick the first one to be blue and the second one to be blue, or we pick the first one to be green and second one to be green. So this is it. So that means it's either we have red or blue or green. So we look for their individual probabilities and add them together. So the probability of picking the first one to be red, how many red balls are in the bag? We are having 3 red balls over the total number of 15. By the time we pick the first one to be red, you realize that the remaining red balls there will have to be 2. The total number of balls have reduced to 14. So that means we'll be having what? 2/14. The probability of picking the second one to be red. So that means we are now going to multiply them together, because both of them will happen simultaneously, or because it's either this one or this or this. So we now add it to the result of when we have blue. If we have the first one to be blue, how many blue balls are there? We are having 5. The total number of balls is 15. By the time we remove one blue ball, we are left with 4 blue balls. So the total number of balls in the bag has also reduced to 14. So the probability of picking the second one also to be blue is 4/14. So you multiply this, so this and this, then, or that means plus the probability of picking the third one to be green. The probability of picking the third one to be green, how many green balls are there? We are having 7/15. If you pick one green ball, it will remain 6. The total number of balls will be reduced to 14. So the probability of picking the second one to be green was 6/14. So you multiply 7/15 times 6/14. So let's try to do this. So now we'll be having 3 here 1, 3 here 5, 2 here 1, 2 here 7. So that means you'll be having 1 times 1 will give us what? 1/35, plus 5 here 1, 5 here 3, 2 here 2, 2 here 7. So 1 times 2 is what? 2/3 times 7 is 21, plus, so 7 here 1, 7 here 1, 7 here 2, 3 here 2, 3 here 5. So what again can divide? 2 here 1, 2 here 1. So that means we having 1 over 5. So we having 1 over 5. So the LCM of 35, 21, and 5. So the LCM of 35, 21, and 5 will give us 105. How many 35 are here? 3. 3 times 1 will give us 3. Plus, how many 21 are here? We having 5. 5 times 2 is what? 10. Plus, how many 5 are here? 21. 21 times 1 is what? 21. So 3 plus 10, 13. 13 plus 21, that will give us 34 over 105. Is there any other number that can divide them? No. So that means the lowest term is what? 34 over 105. So the probability of having the same color, that it can be red or blue or green, we have it as 34 over 105. For the last part of the question, we say that the probability of having both to be of different colors. This can happen in different ways. So it's either if we having red, blue, green, red, blue, green. So either we have red, blue, red, green, or blue, red, blue, blue, green, green, red, green, blue, green. So now that means if it's either for them to be of different color, it can be red, blue, or red, green, or blue, red, or blue, green, or green, red, or green. So that means the probability of us having different colors will be probability of the red, blue, or probability of red, green, or probability of blue, red, or the probability of blue, green, or the probability of green, red, or the probability of green, blue. So let's now look at it one after the other. The probability of picking the first one to be red, we having 3 red balls over 15 balls. By the time we remove 1 red ball, it will remain 14 balls there. The probability of picking the second ball to be blue will be what? How many blue balls will still be there? 5 over total remaining balls, that is 14. Or because of this, or that means it's either this or this, that means we had the probability of red to be first ball 3 over 15 times then red and green to be the second ball, that be 7 green ball. The total number of balls are reduced to 14, plus the probability of picking the first ball to be blue is 5 over 15. So the next ball to be red, we having 3 red balls there. The total number of balls has reduced to 14. Or that is plus the probability of picking the first ball to be 5 to be blue is 5 over 15, and the second ball to be green is 7 over 14, plus the probability of picking the first ball to be green is 7 over 15 times second ball to be red is 3 over 14, plus the probability of picking the first ball to be green is 7 over 15 times second ball to be blue is 5 over 14. So we are going to resolve this. So that means you have 3 over 15 times 5 over 14. That should give us, if you resolve that, you are going to get 1 over 14 plus the probability of 3 over 10 times 7 over 14 will give us 1 over 10. And 5 over 15 times 3 over 14 will give us 1 over 14. 5 over 15 times 7 over 14 will give us 1 over 6. 7 over 15 times 3 over 14 will give us 1 over 10. 7 over 15 times 5 over 14 will give us 1 over 6. So we are going to resolve this. The LCM of everything here is 210. How many 14 and 2, 10, 15. 15 times 1 give us 15. How many 10 and 210? We having 21. 21 times 1 is 21. How many 14 and 210? We having 15. 15 times 1 is 15. How many 6 are in 210? We have in 35. 35 times 1 is what? 35. How many 10 are in 210? We have in 21. 21 times 1 is 21. How many 6 are in 210? We have in 35. 35 times 1 is 35. So when you add everything here, you are going to have 142 over 210, which to the lowest time to give you 71 over 105. Alternatively, if we decide, since we have been able to know the probability of picking of the same colors, we find the probability of picking the same color to be 34 over 105. It's either we pick the same colors or different colors. So we can say that to know the probability of picking different colors, we just subtract this 34 over 105 from one whole number. So alternatively, to pick a probability of different colors is equal 1 minus probability of picking the same color. We have look for the probability of picking the same color to be 34 over 105. Just subtract it from one whole number. So this one is same thing as 1 over 1. LCM of 1 and 105 is 105. How many 100? 1 and 105. 105 times 1 will give us 105 minus 105 in 105. 1 times 34 is 34. 105 minus 34 will give us 71 over 105. You can see that we got the same answer in the two situations. Please, now for the work practice. Number 1, a crate of soft drink. A crate of soft drink contains 9 bottles of Coke, 6 bottles of Pepsi, and 4 bottles of Clinker. Ademola picks 1 bottle of soft drink without replacing, and thereafter Adedeji picks another bottle. Find the probability that they both picked Nimca. B. Ademola only picked Nimca. Ademola only picked Pepsi. C. They both picked the same brand. Then D. They picked different brands. Then number 2, a box contains 5 blue marbles, 3 black marbles, and 2 red marbles of the same size and shape. A marble is selected at random from the box without replacement. A second marble is then selected. Find the probability of obtaining 1, 2 red marbles, 2 blue marbles, or 2 black marbles, 3 1 black marbles and 1 red marble. Number 3, a bag contains identical stones, of which 12 are painted red, 16 are painted white, and 8 are painted blue. 3 stones are drawn from the bag, one after the other, without replacement. Find the probability that A. 3 are red, B. the first is blue and the other 2 are red, C. 2 are white and 1 is blue, D. they are of the same color. Please ensure you like, subscribe, and comment on this video. And you can reach me on my WhatsApp contact, which is 08068309191. Thank you.